All right, so we are in Unit 8 now, and I'm excited. This is one of my favorite units because it's like puzzles, and so there's not a lot of math. And so let's just jump right on in. So the first thing that we're going to talk about is we're going back to sine, cosine, and tangent. I know we just got off a bunch of graphing, but we're going to go back to these. And so if we remember, we had our unit circle, and in our unit circle, we created these reference angles that we had, and then with our reference angle, we had an x, we had a y, and we had our hypotenuse, and our hypotenuse is what we call the radius of the circle, because here's what our circle is going to look like, okay? And so we have this radius, we have our x, and we have our y. And so what we said was sine, even though we know this is opposite over hypotenuse, we looked at this as y over r. And cosecant, so remember sine and cosecant are inverses, we would say that this is r over y, so we're just flipping them. So our cosine, and I'm just going to write this here, even though I don't want you to think about it like this. Our cosine function is our adjacent, so it's an adjacent to our reference angle. So we would have x over r, and then this would be r over x. So our inverse, which is secant. And then our tangent is our opposite value, so y over x. And then we said that the inverse of tangent was cotangent, so this would be x over y. So this is not new. This is everything that we did in our first unit, Unit 7. All right, so let's go over here and let's look at this reference triangle. So one of the things that we know is we have an x and we have a y and we have an r, and so we have this right angle. So if we don't know what our radius is on this, we can calculate that, and we know that because we have the Pythagorean theorem. So if I took x squared plus y squared, this would give me r squared. And this is going to be an incredibly important concept here in a minute. But all of this comes back to just this right triangle that we had from our unit circle. All right, so which trig function is the reciprocal of sine? Well, we just said that. That is cosecant. And reciprocal of cosine is secant. And reciprocal of tangent is cotangent. So now what we're going to do is we're going to talk about these reciprocal identities. So what I really didn't talk about is what Unit 8 is. Unit 8 are going to be proofs. And it's not proofs in terms of math, but it's proofs in terms of all of our trig functions. So sometimes what we're going to have to do is if we see something like 1 over sine, we are going to convert that to cosecant just to simplify things. The flip side is if we see something like this, 1 over cosecant, we know that that is going to be sine. So these hopefully aren't things you have to memorize. This is kind of logic. So if sine is in the denominator, then the inverse of that is going to be our cosecant. All right, so we have the same thing here. We would know this would be secant, this would be cosine, this would be cotangent, and this would be tangent. All right. Okay, so now here is an example of a proof. And so I'm going to go through this first proof here in terms of y, x, and r, and then we're just going to know that this is true moving forward. All right, so if we go back up here, we said sine is y over r. So my sine function here is going to be y over r, and my cosine function is going to be x over r. Now, if I go over here and do a little old school division, and I'm going to do this one time and then I'm not going to do it again, so y divided by r divided by x divided by r. So what we know here is when we do this old school division and we look at this as in form of keep, change, flip, I would have y over r times r over x. So really what's happening right here is that I have y r over x r. So when I flip this, when I multiply across the top, I have y r. When I multiply across the bottom, I have x r. So hopefully what you see here is that my r's are going to cancel out. Now they would have canceled out over here as well. And what I end up with is y over x. Now, let's go back up here. What do we get when we have y over x? Well, y over x is the equivalent of tangent. So this becomes tangent theta. Well, if I look at this, reciprocal, so my reciprocal here, or actually it's not reciprocal, I'm just flipping these, right? So these two are going to get flipped. So I have x over r and y over r. That's my cosine and my sine. So now that I know how this works, I have x r over y r. And my r's are going to cancel, and this is going to give me x over y. All right, well, if I go up here, what is x over y? X over y is cotangent. So we know that this guy becomes cotangent theta. Now, why is this important? This is important because sometimes we're going to have the function cotangent, we're going to have the function tangent, and one of the things that we're going to do is we want to simplify this, cotangent or tangent, and the easier way to simplify it is to turn that into a sine or a cosine function. And you'll see what that looks like when we actually start doing some proofs. So our first reciprocal identity here that is a little bit new is when we have sine over cosine, that is the same as tangent. And when I have cosine over sine, this is the same as cotangent. So these, you're just going to have to, you can logic through them if you need to, or you're just going to have to know what these are. All right, so now let's go back and let's look at this in terms of this. This is our first Pythagorean identity. And so what we said, I'm going to flip this back over, is we said that sine is y over r and cosine is x over r. So if I have sine squared, what I have here is y over r squared plus x over r squared. All right, so I have y over r squared, x over r squared. And when I do the math on this, I have y squared over r squared plus x squared over r squared. Okay, now if I simplify this out, y squared plus x squared equals r squared. Now, if you look at this, you're like, okay, how is this any simpler than what I had over here? But look what happens. If you remember a minute ago, I said we can solve this with Pythagorean theorem by saying x squared plus y squared equals r squared, right? Now, the order here doesn't matter because I'm adding, so I can say y squared plus x squared equals r squared. Well, look what happens. I have y squared plus r squared. So what this becomes is r squared over r squared. And because I have this is the same value, this becomes 1. This is a perfect example of a proof. I didn't solve anything. I just took what I know about sine, what I know about cosine, what I know about Pythagorean theorem, and I end up with 1. So our first Pythagorean theorem is sine squared plus cosine squared equals 1. And you can flip this around and you can say cosine squared plus sine squared equals 1. And I am really, really bad about putting my angle on here. And so when you see this, just know that if I forget to put the angle on here, you've got to have an angle here. The other thing that I'll do when I do proofs, and something that just helps my mind, because when we start manipulating this formula, sometimes you'll just see me do this. And really what I'm saying here is cosine squared plus sine squared equals 1. So if you see this on an answer key, if you see this on anything, this is my logic of just saying, okay, I know what this Pythagorean theorem is, so I'm just saying cosine squared plus sine squared equals 1. And you'll see what I mean when I say manipulate this, when we start subtracting and doing some things in there. Okay? All right, so this is what I would tell you probably the most important ID that we're going to do in this whole unit. You're going to use this more often than anything else. So this is the first unit. Now, I've given you a cheat sheet in your packet, and the cheat sheet is this. And so we've already talked about some of these. So we said tangent is sine over cosine, and cotangent is cosine over sine. So these are what we call quotient IDs because we're dividing. Okay, then the next thing are the reciprocal IDs, which are these. These are the reciprocal IDs. All right, so we just did our first Pythagorean ID, which is sine squared plus cosine squared equals 1. Now, when you do a proof, you are not going to have to go in and prove it the way I did up here. You just have to know that the Pythagorean ID is going to be sine squared plus cosine squared equals 1. So this is what's important, not this. I just want you to see what it looks like when we do a full proof. Okay, so now this says take the Pythagorean ID and divide every term by cosine squared. So Pythagorean ID, that's this one. Don't forget this. So I'm going to divide this by cosine squared theta, and I'm going to divide this by cosine squared theta, which means I have to divide this by cosine squared theta. Okay, so here we have another proof. Okay, and so what happens when I do this? Well, when I do this, cosine squared over cosine squared, this guy becomes a 1. And I have sine squared over cosine squared. Well, let's look at this. If I have sine over cosine, which is what I have down here, sine over cosine, and I square this, then that means this whole term that's right here, this whole term is going to become tangent squared theta. All right, so now if I have this ID, which is 1 over cosine squared, if I look at my cheat sheet here, when I have 1 over cosine squared, I have the reciprocal identity of secant. So because this is squared, this whole thing becomes squared. So 1 plus tangent squared equals secant squared. This is my next Pythagorean ID. Now, I've got a little cheat on how to remember this. So here is what this is. This 1 looks kind of like an I. So what I say is I tan in a second. And that's kind of my stupid little way to remember this ID, because you're not going to have your cheat sheet on everything, so you're going to have to remember this. So I tan in a second. 1 plus tangent squared equals secant squared. Now, because if you think about the Pythagorean ID, everything is squared. X squared plus y squared equals r squared. Everything in my Pythagorean IDs are going to be squared. All right, so now we're going to look at the Pythagorean ID that we have. So our standard one, cosine squared plus sine squared equals 1. And now I'm going to divide everything by sine squared. All right, so what we see here is cosine over sine. So if I come up here, I have cosine over sine, which is cotangent. So this first term that's right here becomes cotangent squared theta. Right? Now, I have sine over sine, so that simplifies to just 1. And then if I look at my reciprocal IDs, 1 over sine is cosecant. So this guy right here becomes cosecant squared. So this is my next Pythagorean ID. Now, I'm going to move this around, and then I'm going to give you a stupid little thing. So 1 plus cotan squared equals, forgot my C, cosecant squared theta. Now, these two things are the same. So same thing. I can go back here and I can say tan squared plus 1 equals secant squared. So the order, I can mix the order around just like I did this Pythagorean ID. All right, so if you didn't know, I grew up in Colorado, and so my cheat on remember this is I, because remember I think this looks like a 1, this looks like an I sleep on a cot in Colorado Springs, Colorado. Okay, so let's look at this. I sleep on a cot in Colorado Springs, Colorado. So it's stupid. If you just can memorize this, that's great. If not, that's a fat cheat for you. All right, so this ID, I tan in a second, so this is going to be secant squared. I sleep in a cot in Colorado Springs, Colorado. So these are the other two Pythagorean IDs. You have to know them. So between these three, we're going to use these more often than anything else. All right, so again, the first thing to notice is that these are all squared IDs. Every one of these is squared. Even this one is still squared. When I reduce this down here, I don't say 1 squared because we know 1 is squared, but everything here with the Pythagorean IDs has to be squared. Okay. I'm not going to fill this out. You can fill this out on your own. Let's flip it over. All right, so let's do a little bit of a proof on this. So here are our first proofs. So what this says is use the trig IDs to write an expression in terms of a single trig function or a constant. So right now I have sine and I have cosine. So this doesn't tell me anything. Nothing is squared. Nothing tells me anything. So the first thing that I'm going to do, and this should be your first strategy, is going to be convert to sine or cosine. So I'm going to convert everything to sine or cosine. So I know tangent is going to be sine theta over cosine theta, and I'm multiplying this by cosine theta. Now, I'm not going to put this cosine theta over 1, but what's happening here is I'm multiplying. So if I'm multiplying, these two cancel out, and this whole thing becomes sine theta. All right, we look at this next one. So what should pop in your head right away is that I have a squared term. And if I have a squared term, then I'm probably going to use one of the Pythagorean IDs. So I've got cosine squared that's in here. So if I go back and I look at my Pythagorean IDs right here, these are the Pythagorean IDs that I have. So no cosine here, but I do have a cosine here. So one of the things that I had mentioned a minute ago is sometimes we have to manipulate this formula. So what I really have in my Pythagorean ID is sine squared theta plus cosine squared theta equals 1. So if I take this cosine and I subtract it and move it to the other side, then what I have is sine squared theta equals 1 minus cosine squared theta. And now what you see is that this guy can be simplified up here. So what this gives me is sine squared theta, because I'm going to simplify all of this. I'm going to replace it with 1 minus cosine theta over cosine squared theta. And when I have sine over cosine, go back to this, sine over cosine is tangent. So this whole thing simplifies to tangent squared theta. All right, let's look at this one. So here I have cosine and cosecant. Well, I don't have anything squared. So if I don't have anything squared, then I want to go straight into converting to sine or cosine. Actually, let me do this. This is going to be the second strategy. When you see something squared, you might have to manipulate it. All right, so nothing squared. So what I end up here is cosine theta times 1 over sine theta. So our reciprocal identities, we go over here. All of these flip. Now, I don't have, I guess I do have cosecant on here. But remember, you can flip either way. So 1 over sine is cosecant, or cosecant is 1 over sine. So what I did is I replaced cosecant with sine. Now, if you remember, the strategy here is to convert to sine or cosine. The strategy is not to convert to cosecant, secant, or cotangent. So we want to go to our most simple, and our most simple is always going to be sine or cosine. So I'm multiplying across the top, and I'm multiplying across the bottom. So now I have two things, cosine over sine. So if I look back on this, I have cosine over sine, which is cotangent. So this becomes cotangent theta. All right, what do I have here? I only have sine, secant, and tangent. Nothing is squared. So if nothing's squared, I'm going to use strategy number 1, convert everything to sine or cosine. So in the numerator, I have sine theta over 1 over cosine theta. So inverse of secant is cosine. In the denominator, I'm going to have sine cosine, or sine theta over cosine theta. So remember, I convert everything to sine or cosine. So when I multiply across the top, what you should see is that you have sine over cosine in the numerator and sine over cosine in the denominator. So all of this is just going to simplify to 1. All right, now this is important because we're going to go back to old school fractions, and we did this on the other side, but these are going to get more complicated. Our trig functions are, so we're going to go through and just practice these really quick. So what I have here is 2/3 times 15 over 4. Now I could multiply across the top and the bottom, but it's better if I simplify first. So if I simplify this, what I end up with is 5 and 1 and 1 and 2. So this whole thing simplifies to 5 over 2. Okay, go ahead and pause the video and you do the rest of them and then come back and check. All right, so here's what your answer should be. This one, D, is a little tricky. So I did this old school and you end up with 1/4. All right, so now, hold on, I should have one more page. Okay, last page. So let's go through these. This is the same thing. We're just going to make these a little more tricky on here. So I have cosecant and cotangent. So nothing is squared. So remember, the strategy is turn this into sine or cosine. So what I end up with is 1 over sine. And then this becomes, cosine over sine. So my strategy here, I would have 1 over sine theta times sine theta over cosine theta. So I flip this in the denominator. So these cancel out. This gives me 1 over cosine theta, which simplifies to secant. So all of this becomes just secant theta. All right, so now what happens? I see squared functions. So I see squared functions on here. So if I see something squared, I'm going to look at this. I see a 1, so I know this is a Pythagorean ID. So I have sine squared plus cosine squared equals 1. So sine squared is going to be 1 minus cosine squared. All right, so this 1 minus cosine squared is replaced with sine. So I have sine squared divided by, I've got to get rid of my tangent, so my tangent becomes sine squared over cosine squared. Now, because this is all division, this is the same as sine squared times cosine squared all over sine squared. Right? So this time when I flipped it, I just put this together, made this the denominator. My sine squareds are going to cancel, so the whole thing simplifies to cosine squared. All right, we have a couple more. So not squared. So if it's not squared, I have to convert to sine or cosine. So I end up with cosine squared times 1 over cosine squared. And all of this is sine theta over cosine theta. Well, what I see in the bottom is, in the numerator, is that the cosine and the cosine go away. So I end up with a 1. And this becomes sine over cosine. So sine over cosine is tangent. So I really didn't have to simplify this, because what did I do? I went right back. So why did I go right back? Well, I went right back because I know that the reciprocal ID of 1 over tangent is cotan theta. Now, let's say that I didn't see this and I kept it here. So because my numerator is 1, this guy would simplify into cosine over sine. And if we looked back at our IDs, get my cheat sheet here, cosine over sine is the same as cotangent. So this guy equals cotangent. So whether I did it this way or whether I did it this way that's in the red, I still end up with cotangent. This is the first example of a problem that you could do 2 different ways, but you end up with the same answer. So if you remember our introductory idea where we took a word and we got to the same answer 2 different ways, this is exactly what this looks like. I'm going to get to the same answer 2 different ways. All right, 2 more. We're almost done. So sine and cosecant is 1 over sine. So what happens here is this is the same really as saying sine theta over 1 over sine theta. And so when I do that, keep, change, flip, what I end up with is sine squared theta. And that's my final answer. Now, I know it says write each term as a single trig function. This is a single trig function. It doesn't matter that it's squared. I only have one function, and that one function is sine. Okay, so last one here. I see a bunch of different things that are squared. So when I see all of this squared, I need to think Pythagorean ID. So I'm going to leave sine squared because it's as simplified as it gets. And now I have secant squared plus cosecant squared. So this is 1 over cosine squared theta plus 1 over sine squared theta. All right, so now this doesn't look any more simplified, but what I'm going to do is I'm going to distribute to everything on the inside. So if I distribute, I have sine squared over cosine squared plus sine squared over sine squared. Now, when I simplify this, if I have sine over cosine, I know that this is tangent squared theta, right? So sine over cosine would be tangent. That's this one. Sine over cosine's tangent. But when it's squared, then my function's squared. This simplifies to 1. Now, this is my I tan in a second. So this whole thing becomes secant squared theta. I tan in a second. So here's my final answer. All right.